let's talk about lab 12. Lab 12 has to do with potentiometers. Okay, so this is kind of one of the schematics you're going to build. You'll be doing a couple. This is the second schematic. But before we get there, let me remind you about what a potentiometer is and how it works. It's been a little while. So I saw this little graphic I thought is pretty cool. It kind of shows that there are 3 pins on a potentiometer. On here you can see they're labeled A, B, and C. And pins A and B don't change. So the resistance from pin A to pin B in this case is always 100,000 ohms. The thing that's changing is the middle pin, pin C. Okay, and depending on how far you turn the screw, that's going to determine how much resistance you have. Okay, so let's take a look at an example here. So let's say we have a 10,000 ohm potentiometer. And first of all, everyone's going to ask, in my parts kit, I have 2 or 3 potentiometers. Which one is the 10,000? Well, think 10,000 is 1 0 with 3 zeros. So it's a 103, right? Now 1,000 ohm would be 102. So that's how you know. Okay, so this is a 10,000 ohm potentiometer, and when people refer to it like that, they're talking about the maximum resistance it can have. Because every potentiometer can have 0 ohms if you turn the knob all the way down. But yeah, so that's what it's referring to as the max. So if you have your screw set kind of halfway right there, that means if you measure from the left pin to the middle pin, you would have 5,000 ohms, and same from the right pin to the middle pin. Okay. Now, if we turn the screw, now we'll have less resistance on the left, but they still will add up to 10,000. Okay. So picture if you want a variable resistor in your circuit, you just connect it to the left pin and the middle pin. You don't even need to use the right pin because this is almost like 2 variable resistors in one, and you only need half of it, you know? So really, just a kind of practice I always do is just use the middle pin and then pick one of the 2 sides, okay? Now, if you put a wire here, okay, that is a short. That is actually a physical wire that shorts out this part of the potentiometer. Okay, if you did that, then this 3,000 ohms is no longer 3,000, right? It is 0. And now the total resistance from the left pin to the right pin is 7,000 ohms. So when you put this wire in here, it is now known as a rheostat, R-H-E-O-S-T-A-T. And that just means a potentiometer with a wire. So now if I turn the screw, watch what happens. If I turn it and now it's way over here on the right, the entire potentiometer is 2,000 ohms. And if I move it to the left and to the left again, so you're basically just shorting out different amounts, right? Look at this wire, look at this short right here, right? It's shorting out different amounts of the potentiometer. All right. So you don't, I mean, some cases you want to put that wire in there, but you don't really need it if you just want to measure from the middle pin to the left pin and just ignore the other half, you can do it that way. Now, there is something to note. Typically, I've mentioned this in the past, if you turn the knob to the right, you would expect things to get brighter, to get hotter, to get louder, okay? And that's assuming you connected to the correct pins, right? So you have an option here. You can connect from the middle pin to the left pin, or from the middle pin to the right pin. Depending on which one you choose is going to determine if the volume goes up or down when you turn it clockwise, right? So you got to make sure you pick the right one. So let's do this one. Let's say we turn the knob clockwise. Okay, the knob's turning clockwise, 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 and this happens. If you want the volume to go up, would it be better to connect from the middle pin to the right or from the middle pin to the left? You want the volume to go up. So that means you would want less resistance. So you would go to the left pin because there's less resistance if you turn the knob that way. If you hook up to the other pins, it'll still vary the volume, it'll just be backwards. And so that's kind of part of the lab today. So let's go to the lab and look at a couple more things. So here is the first circuit, and I'm going to build this one for you. Again, you're going to use your own voltage source. It doesn't have to be 9. And let's take a look. I already built it. Oh, first of all, what is this thing? This is your digital multimeter. So you're going to put the red lead on the middle pin and your black lead on ground. So let me show you a picture of that. All right, so this is the same circuit as that, essentially. Okay, and so these are the 3 pins, and you got your ground here and your power here. So the idea behind these is if your power is, say, 9 volts coming into this pin, and your ground pin is 0 volts, that means your middle pin has to be somewhere between 0 and 9, depending on where the screw is set, okay? So let's say I plug it in and I turn this to the right, and the volume starts to go down, right? What if that happened? You're turning it and the volume's going down. What's wrong? Well, that means this is backwards. All you do is pick it up, flip it 180 degrees. It's hard for you, right? So I flipped it, right? It was like this. I flip it like this and I plug it back in. I've actually had at my old job, whoever did the layout designed the circuit board so the potentiometer was backwards. And every time we went to calibrate this thing, we wanted the peak to grow. You would turn it clockwise like you would think, and it would shrink. And it was so annoying because you would never get used to it. And it's such a simple fix. You just design it so it's mounted the other direction. All right, so that's all it takes. All right, so then you're going to get your leads, and you want to measure the voltage at, say, the middle pin. So you just connect your red lead from your meter there, and then the black lead. Oops, sorry about this. And then your black lead goes to ground. You could put an extra wire in there. And then you're just going to turn it and see what the voltage does. So that's the first part. The second part of the lab is very similar. They want you to create this circuit that you see here. And I try to make it really obvious. It looks like an ugly drawing, and well, that's probably true, but it's also on purpose. Notice how dark black some of this is, and some people miss this. They don't realize that you need to add that short wire. Let me show you what I'm talking about. All right, so let's turn it sideways so it looks more like the picture. This one's hard for people, so I'm going to make this one. Okay, so there's my 3. All right, my 3 pins, and we want to run positive voltage to that 3rd pin. All right, that 3rd pin. Okay, but then you can't forget you need to add the short that's right here. So get another wire and place it from the left pin to the middle pin. If you don't do this, the lab won't work. You need to short out part of this guy. All right, so now the left pin to the middle pin is shorted. Then you need to add a resistor. Okay, so there's a resistor in this lab, and right there you'll add a 1000 ohm resistor. So that would connect to the right pin. And the other side of the resistor would go to ground. Right, and your ground lead from your battery would be right there. So that's this circuit. Okay, let's say you build it and all the numbers are backwards from what it should be. So let me show you. The first number should be roughly 0.8 volts. This is in your lab. If it's not, let's say it's like 9 or something, then take your potentiometer and turn it around. And it should say 0.8, and then you know you're on the right track to fill in this table. And yeah, that should be it for this guy. Good luck.